right away, so I have to redo the intro. Welcome, everybody. What are we doing here? Put my head over here. All right, so all these chats over there, my notes over here. Got project over here, hopefully. Thanks, Peter. All right, so hopefully everybody has got the materials. Pop that right back up here again. Our chapter today, chapter 5. I'll pop that into the chat. Hold on. Oh, there's stuff on top of my chat now. There we go. And then if you need the code for where we're starting, it's this. What I want everybody to do is, so you've got your demo package open. What I want you to do is go into this lower right tab, it might not be lower right for you, into the packages, and make sure that you don't have demo package installed. Oh, I don't. So I can't show you how to uninstall it, but if it is installed, there's a little X over here, and you click that, uninstall it. Because when you're working on developing a package, there's two places it can sort of be installed. It's a little bit confusing if it's in both. So it could be installed for in all of your R so that you could use it in other projects. And it can be installed or loaded. So it's installed versus loaded. When you're developing it, what you want is your package to be loaded. And we can do that up here within our build tab. So don't click install, that installs it onto your computer. You want it loaded, so load all under the more tab. That will run this DevTools load all function. And now demo package is something that you can use in this project session while you're developing. And every time you make changes to the package, you can reload it and then continue using it. So we can do things like see our APA tpair function. So I'll look at the function code itself, or we can access self-res at. You see the pipe that's come up here. This is something I put into, but we didn't actually go over for chapter 3. I put it in later, a way to include functions from other packages and be able to export them. And the McGritter pipe used to be a really useful thing to do because there was no base R pipe. So if you wanted to be able to use the pipe in your examples and just have like a package that was something that was meant to be used with the pipe, you could import the pipe from McGritter and export it for the users of your package to use, so they wouldn't have to put library McGritter or dplyr at whenever they were wanting to use your package with the pipe, that your package would carry the pipe with it. And if you want to do that in your package, the thing you do is to use this function, put in the console, use pipe. If you only want to be able to use it internally in your own code that creates the functions in your package, you set export to false. But if you want users of your package to be able to use the pipe, you can set export to true. I'm not going to run this because I already ran it. But what it does is in your R folder, which is where all the function definitions go, it makes a file called utils-pipe and sets up all this stuff for you. So this is how you grab something from another package. You import it from McGritter. It's a little bit more complicated than typical because it's one of these symbol infix operators, as opposed to your typical functions that have like a function name and in parentheses. The other thing, let's see. Yep, the GitHub link is the package up to this point, up to the end of chapter 4. Oh, Heather Shaw, are you giving demo package zip of yours, or what is on the GitHub? Because the one from the GitHub, the one from this link, okay. Yeah, I would recommend that people get it from this link. I'll show you how to grab it. Let's pop this over here. We're going to demo package. So if you go to that link, don't install it like you would a package that's online. Go to the code and download the zip file that way. Or if you use GitHub, you'll know how to get things off GitHub. All right. What was I gibbering about? Oh yeah, so the other thing that was I added to the end of chapter 3 after our week 3 thing is how to make this kind of file. So demo package dash package. It's the package documentation file. And it creates the help for when you look for help on your package itself. So help demo package. And this bit of text creates the this help here. But also, this is a nice place to put your generic imports. So we had just tucked it before at the beginning at the top of the APA_T_pair. Like if you wanted to import t-test and the SD function from stats, so that you don't have to put stats : t-test every time or stats : SD. You can now just use those because you've internally imported them. So keyword internal here means that you've imported these so you can use them, but you're not exporting a t.test function so that your package is, you can't have a demo package : t.test because that doesn't make any sense. And you can import everything from ggplot2 with this sort of function, which is useful if you're going to make plots because ggplot2 has so many functions that you need to create like more complex plots. You don't want to be putting ggplot2 : in front of everything. All right, so those are the things that might be a little bit different from what you have that's in this the package online on GitHub, because I added those bits to chapter 3 after based on the questions people were asking at the end of week 3. All right, so unit tests. I'm very excited for unit tests today because I just love unit tests. All right, so what we're gonna do is set up unit tests. Let's get ourselves into the base directory of demo package. Now in the console, I want you to type a command from use this. You only need to do this one time for each package that you're creating, and it sets up all the kind of directory structure that you need for testthat. So use this, use testthat, all right? And you're gonna get a bit of stuff. It's gonna change something in your description file. It's gonna create a folder called tests and a folder called testthat inside, and it's gonna write an R file inside of tests. So let's have a look at what that looks like inside of tests here. We've got the testthat.r. You don't need to do anything in here. This is set up, don't modify it. It just is the kind of setup code that needs to run before your tests run. And then you get the testthat directory that doesn't have anything in it right now. The other thing that changed is your description file. So there's now a section called suggests. So remember when we import, we have to import any packages that we're using, functions from those packages in our functions. We're not going to be using testthat in our functions, but we're going to be testing our functions with them. So in our entire package, it would be useful to have testthat. So the suggests to people who download this package that they could have testthat and what version you're using, but does not force them to download it. And that's a way to just document that this package is using testthat. So, but again, use this, just does it all for you. You don't need to do anything with the description here. All right, so now we're gonna set up our first test. So we're gonna create some tests for that APA_T_pair. first, let's have a quick look at, for people who are new this week, what APA T-pair is up to. So hopefully this will be available to you because you've run load all. So APA T-pair, and we can run that on, so this does paired samples APA, paired samples t-test on the X and the Y variables that you feed it. And it sends back APA formatted text to report the results of that test. So we also have a built-in data set called self-res-at. It's got things that we could use for a paired samples t-test. Let's look at f-self versus self-res-at $f_non. Okay, so if you've loaded this, all this should autocomplete for you. And then you get this result. Okay, and you may have done the thing needed to fix the p less than 0.001 when that's applicable. I've not done that yet. That was homework from week 3. Great. So we're gonna test this function and make sure it's doing the things that we want it to do. So when you start a test, and when you start testing a function, if you haven't had created a test file before, use this. Has, again, helpful stuff. So use test, and then we got to tell it what function do we want to test. So we're going to test APA T-pair. It's going to create a file that's inside your test folder. Inside the testthat folder, it's called test-apa_t_pair.r. I have mistyped this, so in the chapter, should be following only in the chapter because all of what we're gonna type is there. You can do a lot of cut and paste. I need to put a test dash right here before that. That's a typo in this chapter. All right, so you get this startup. So whenever you create a new test, it has this demo to kind of show you how our tests formatted. So there's a testthat function, and then you give it a name. The name doesn't really do anything, so it doesn't matter what it is. It just needs to be there. And then inside the curly brackets, you put the code that you're going to be checking, and then an end parenthesis. So the code that we're going to be checking uses functions from testthat to do a variety of types of tests. One of the most common ones is expect equal, which just means that you're going to expect two things to be the same. So 2 times 2 should be equal to 4. So if we run all of this up, then you're going to get could not find function testthat. So load the testthat library or package using the library function just in your console. During the automated testing bit, all that will be done for you. There we go. So you can run this now, and you get in the console, little test passed. I've got a rainbow. You might get a cat that has got a smiley face. I don't know. So run that. Let me know in the chat. Copy paste your emoji. What did you get? This is just so I figure out, like, are people awesome? Okay, so we've got gold medals and cats and little celebrity people and awesome. Okay, so what we're going to do is replace this. There's a really funny, so Jenny Bryan, who makes testthat, did basically a search of GitHub repos for testthat multiplication works, and found so many of them. So change this, because I don't think you're actually testing whether or not multiplication works in anything. What I always start with is defaults. So I'm checking to see, are the defaults what I expect the defaults to be? As the function just basically working the way it's meant to be. And I'm going to take that bit out. All right, so inside these curly brackets, we can put any code we want. And then we need to include at least one or more test functions from testthat. So the first thing we're going to do is check if we get the result we expect from some static data. So we're going to set the X and Y to just small static vectors, like just 1 through 5. And we can set Y is cannot be 1 through 5, or you're going to get a weird 0 variance error. So 2, 3, 2, 5, 6. All right, so we've got 2 5 integer vectors. I know this is not good for a t-test, but it's fine for testing it here. All right, and now we're going to run our APA t-pair function and store the result of it as, we'll call the variable result. You can call it whatever you want. APA t-pair X and Y. All right, so while we're developing this, let's run each line by line, not this whole function, but just this line. So define X, define Y. Let's have a look at the environment. There they are, and the result. Okay, so let's have a quick look at the result down here. And our result is a paired samples t-test was conducted to compare the DV between level 1, M equals 3.0, SD 1.6, level 2. There was a non-significant difference. Okay, that all looks sensible. I'm actually just going to copy paste that because I think it's working correctly. You could be a little bit more complex and like work out for yourself before even looking at the result. What did you expect? But I'm going to create another value or another variable called expected. And that's just going to be this. So I'm going to put what I got. So I know for sure this is going to turn out right. But if in the future I mess up the APA t-pair function, it doesn't give me this, then I'll know that something's gone wrong. All right, so we've got our result, we've got what we expected, and we run our test. So we want to expect that these two things are equal, the result and expected. Whoops. So we run that, we run this, nothing bad happened. If we do something like change that to a 3, we need to run this again to redefine expected. And then we get an error message that says actual not equal to expected. And then this was what we actually got. And this was what was expected. And then you get to look in here and see like, where's the difference? Oh, it's right there. All right, so let me fix that. I'll save this. Now, because this is all bundled together, all that code will run and the test will run. So you can run the whole thing and then you get test passed here. All right, so right. And instead of kind of running it this way, you can also run it just with the little button up here in the top right, run tests. That will run this through in the build tab. And you can see here, it'll load your demo package and then it will give you a sort of overall how many tests are passed because you will have more than one test. You can put more than one test inside of one test chunk, or you can create separate test chunks. This is really kind of the a stylistic thing. I like to break them up into kind of logical groupings so that I can think about all these tests and run them in a chunk to see if they worked okay. So I might put several tests about the defaults in this chunk and then create another chunk that does a semantically different thing. You can put all of your tests for one function inside the same chunk if you want. It will eventually get a little bit confusing, I think. All right, so let's make a second test chunk. So test that, and we'll do non-defaults. So if we change the defaults, what's going to happen? So non-defaults is the first argument to test that. The second argument is the code. So inside curly brackets, and then you have the closed parenthesis. So skip a line there and pop our code in here. So what we can do, copy this bit. All right, So just this bit, result and what we're going to expect, but we need to change the defaults to something else. So set the DB to the score. Just put that a little bit more space in here. And the value for level 1, we will call that group A. And our value for level 2, we'll call it group B. So what do we expect to change in our expected bit? It won't be the DB, but it will be the score between group A and group B. So we expect this result to change here. So we can run that, run this, and that's correct. If say 2 of 3 pass in the same chunk, the whole chunk doesn't fail, James, it will tell you that 2 of your 3 tests have passed. The chunks really don't do anything. I'm not sure what they're there for. And the names also don't really do anything. You don't get a readout of which named things are failing or not. But that's how it's structured. Now, if we run test that, this whole second function, that's passed. Hold on. I'm going to restart R. Sec. Oh, I need library test that. Okay, so or maybe if I run tests this way, this is gonna fail. So we've passed 1, we failed 1. Let's see what this looks like here. So they tell you error is in line 12, third character. So the error is right here at the beginning of the second test. Object X not found. And that is because we defined X and Y here inside of that set of curly brackets. And this is like a standalone function. Therefore, things we create inside of it are not available outside of it. So if we want this X and Y to be available to multiple test that functions, we can put them outside, like up here. So this should run, or we can define them at the beginning of each test that chunk. But this is a pretty common thing where when you're working interactively, you've defined these, they're in your environment, you're checking each test that thing independently, and it's still in your environment, so it works fine interactively. And then when you run the tests sort of non-interactively, everything's broken. And it's probably because something you thought you had defined globally is only defined inside of one test that chunk and isn't available in another test that chunk. All right, so now, hopefully, if you've run that, you've got pass 2, test complete. You have failed, not failed, you have succeeded at everything. So we can save that. I'm going to talk a little bit about test-driven development. I think this is an outstanding method for starting to develop an R package, doing it in a test-driven way, that once you've written a few basic functions for your package, then you switch over to test-driven development, which is that whenever you want to change anything, you write a failing test. So that you don't write any code until you've written a test that fails, that checks to see if the thing that you want to change has happened, and it will fail because you haven't written the code to make it happen. And then you go write the code, and then it's happened and your tests pass. This sort of is backwards from a lot of ways that people think about testing, in that they write their code and then they think about how should I test the code? And then you got to write some tests, and then you forget to write tests and your code's not very well tested. Here, if you promise yourself you're never going to write any code until you've written a test that has failed, and then you write the code until the test passes, all of the things that you're putting into your code are now have a corresponding test. So let's give an example of this. So let's say if X and Y are completely identical, what we should get is like a warning, because the result's going to be weird. If X and Y are identical, that's almost always a mistake. Like it might happen that you have paired samples where your pairs are identical. But what that does is like you can't really calculate stats for that anymore because the standard deviation of the difference score is 0. And then you're going to get some divide by 0 problems. So let's start a test that function down here. That. Let's call it same X and Y. So basically all this does is like, it's like comments to yourself. What am I doing here? Okay, so let's write a test that fails, that we're not getting a warning when the X and Y are identical. So let's set X to something, 1 through 5. I'm just gonna, actually, we don't need to redefine it here because it's already defined all the way up here. I just need to make sure it's in the environment. All right, so if we have our APA-T pair, and if we're comparing X and X, let's see what that looks like. I can't find APA-T pair because I restarted and I didn't reload. So I gotta load all. All right, there we go. Okay, we're gonna get an error here, and that is because we can't calculate a p-value. Like t results there isn't working because there's no variance. And so we actually can't even run this bit of code. So this is a missing value. T results doesn't have a p-value in this circumstance. So we should probably give people, send people a warning. So how we check in with testthat if a function is creating a warning is expect warning. So we'll just surround our code that's going to give the warning. You can put curly brackets around it if you want, but you don't have to. So expect a warning here. So we're going to run that. And what have we got? There we go. So our test has failed. We've got an error, but also we don't. Okay, actually, let's expect an error. Okay, so we are going to get an error. I don't know why I wrote this for warning, because nothing works in this circumstance, you should actually get an error back. But we want to check that it's like a sensible error. What we have right here is an error that's error in this bit, which isn't going to help our participants in any way. Our users. So what we want is an error that makes sense. So we can expect that the error itself is a helpful thing. So let's say, what do we want the error to be? We want the error to be X and Y cannot be identical, right? We just want to tell people that and spell it correctly. So if we run this, oh, I've forgotten another thing. Okay, so expect error. Let's look at the help here. We're going off piste a little bit. We don't want to ignore case. We want to. So this is a regular expression, which can be annoying. Here we go. Fixed equals true. That's what we want. So we've got our function that creates the error, the text of the error, and we want to say fixed equals true. That means that we're comparing it to exactly this text, not a regular expression, because sometimes the error text will differ depending on what the inputs are, and you want to use a regular expression to check it. But let's not do that today. There we go. All right, so run that whole thing. Okay, our test failed. We've written a failing test. Let's quick. Okay, we're going to use, unlike the chapter, we are going to use expect error, because actually I made a mistake. We don't want a warning in this case because we can't actually like do all of this if they're identical. We just need to tell people you can't run a paired samples t-test on two identical vectors. So we're going to give people an error message rather than warning. And I will edit the book chapter to fix this later. Okay, but our error message is not this, it's this confusing thing. So now we need to go edit our function and fix all that. So back into the main directory of our demo packages. Inside of R, we're going to edit self-res.at. No, we're not. We're going to edit APA t-pair. Okay, so let's have a look down here at our function. And what we're going to do is at the very beginning, before we do anything, we're going to do our error checks. So let's make a note here, error checks. All right, so we're going to double check if x equals y. Now, x and y are going to be vectors. So if we want to check if they're full on identical to each other, you have to do all x double equals y. So let's do a little bit in the console for checking this out. So, oops, what happened there? There. In the console, x double equals x. We'll get true, 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 true. An if statement only works off the first true. So what we want to do is check, are all of those true? So all x equals x is just true. X equals y here. So at the moment, our y is different from our x. These are all false. But if we do, what's that? X equals 2 through 6 here. So the first one's true, others are false. So if we do something like if x double equals y, p else f, you're either going to get t or you're going to get an error, depending on what settings your R has. So some people's R can be set to let you do this sort of thing. I've specifically set mine to disallow this, that if I try to set a vector of length more than 1 as the condition for an if, I get the condition has length greater than 1 and it's an error. You can change that and make it just a warning, but that can get you in all sorts of trouble when you're coding packages. So that's why we're doing here, if all x are equal to y, then what are we going to do? Then we can get rid of this TLSAF bit. So if that condition is true, this is bad, we need to raise an error with the error function. And our error is this text. X and y cannot be identical. All right, so I know in the chapter it says warning, and it's got the values for y and x and y should probably not be identical. We're saying like they cannot. It's now an error. This function doesn't work anymore. Once you've called an error in a function, the function stops. None of the other code after the error stops, it just returns the error. Right, so we've done that error check. We're going to save this. And we want to reload, stay in the build. Reload. So we're going to reload our demo package. So APA t-pair now includes this new function. And hopefully, when we test it, could not find function error. Can somebody remember what is going, why the function error isn't existing? Have I got the wrong? Oh, no, just stop. It's not error, it's stop. Let's reload that. And now our test hopefully has passed. I'll put this back up. And I'll pop that code into the chat here in case anybody needs it. All right. So can you post in the chat when you've got this bit working, that you've added that error check and your test now works? So when it's worked, paste into the chat what message you got. Awesome. All right. Okay. So test should pass. Now we've got, says we've got 5 tests for this one. I don't know. We've got 3 tests for this function. So we've got our couple of tests. We can do that run test, so that runs everything. So that when you click run test, it loads demo package to make sure that everything's updated from any changes you might have made in function definitions, and tells you how many you've passed. You can also, I feel like it's always nicer if you click this test button in the build tab. So this run tests just runs the tests in this file for this function, which is useful when you're kind of working on a function. If once you've kind of made a few changes to your package, you want to test everything all together, because sometimes changes you make to one function will have knock-on effects on another function. And so there are tests of other functions you want to run them to check. So the test button in the build pane tests everything. We've only got one, but and the interface is nicer and more colorful here. So it will show you a table of each of the contexts are the file, like test APAT pair, and then tells you how many of them were okay, failed, or gave warnings that were unexpected warnings, or were skipped. So sometimes you want to skip tests because you can only do them if you're online, or they take a really long time and you want to manually turn them on and off. And then it gives you a summary of how many failed, were warned, skipped, and passed overall, and how long the whole thing took, which will be useful at some point. Oh, Tom, we need vectors X and Y for the third test. We just need vector X for the third test, but it's still defined up here. So we're just checking like when X and Y are the same thing, which is X, what happens? All right, so so we've gone through one example. Now let's just do it again. You can set up test for a data object as well. So we're going to pop back into the console, use this, use test, and then put the name of our data object. So self_res_at. So we're going to make a test file for our data object, and it's going to pop up the demo. Multiplication works. It's going to be down here again inside of tests, testthat, self_res_at. Right. So we can just copy this from the textbook, get rid of that. So we're going to check and see, is the data available? So if we use the data function to load self_res_at, then we can use the expect true function. So expect true is just like, is the value of this thing true? And that's also, it would be the same as expect equal, where the second thing is true. So if we run the exists function, does self_res_at exist? So at the moment, self_res_at does not exist in our environment. So if I run that, oh no, it is true because it exists as an object loaded by the demo package. But this will all run in an environment where the demo package isn't loaded yet. And then we'll pop the data in. We can also check, I'm just going to put that in the, some other things about the data, like does it have the expected number of columns? Does it have the expected number of rows? So we can check and see, does it have 16 columns? Does it have 108 rows like we expected? And one thing that might go wrong with our data set. So we might have, if we went in and edited the code for it, imported that data, and we forgot to turn sex into a factor type, that would be an error. We want sex to be a factor. So let's double check if that's true. So is it true that self-res@$ sex is a factor? We run that, that's also true. Run all of that. Pass all of our tests. So if you save this file, we've got 4 tests inside here. If you run it that way, it'll look like this. And now we can run both of these files, APAT pair or test APAT pair and test self-res@, with the little test button up here. It just runs DevTools : test for you, but puts everything up in that window. You can run it down here. And that's the same thing, whether it's in the build window or in the console. So we've got 3 tests that all pass for APAT pair, 4 tests that pass for self-res@. Everything is passed and you win. Sometimes you get a really nice motivational message down here and sometimes you don't. All right, let me check the chat. How are people doing? All right, so I think you got your tests are to bomb. That's excellent. Yeah, no, some of them are really cute. And it's always nice to get and there's also some like nice, if your tests fail, if a bunch of them fail, then there's sort of messages telling you like it'll get better. They're as encouraging as they can be. All right, so APAT pair object X not found. So object X isn't found because if you haven't defined it up here, if what you've done instead is define it just inside here, inside test defaults and test non-defaults, then if you run these tests, you're gonna not be able to find X. So then you need to copy X down here. If you're defining objects inside of a testthat, inside the curly brackets in the testthat function, things defined in there are only available in there. But if you define them outside of testthat, so at the very top up here, then this would be available to every function in the rest of this file. So if you do it that way, it should also work. So awesome. Oh, and yes, could not find function error. That was me forgetting how to code again. The function is actually called stop. And we just, and this is a really useful exercise to go through for any function that you are creating, to think about like, what could go wrong? What might be a common thing that somebody might do that's actually not right? And they either need to be warned, like, are you sure you meant to do that? So you can use warning to create these warnings that are you sure? But then the code still continues to run. Or stop to mean, this is an error. We can't go on. We're not going to be able to calculate the results of a t-test with identical vectors. And then give people a useful message. You yourself are probably frustrated by the unusefulness of a lot of error messages, especially in base R. And like when we got to that, if we didn't have this, when we got to the error message that you actually get, which was that you couldn't run this bit of code because there was no p-value in t results, then that was really hard to understand for a user. Like they would say, what even is t results? I don't know what that variable is. I didn't create it. T results $ p-value. How do I fix that? There's no way for them to tell how to fix it. So that's why you create errors that people might commonly do check to see if the error message they're getting is really confusing, and then add in error checks at the top of your function to make them more human readable and tell people, that this is the thing that causes that problem. So that's the thing people need to fix. All right, so Sam, do we need tests for APAT pair for X and Y being numeric? Let's check that. That is an excellent second one to do. So pop into APAT pair. We're gonna do non-numeric X or Y. So that's the condition that this is the failing test we're gonna do. We're gonna do some test-driven development. So first, let's just do like X equals letters 1 through 5. Y will be the numbers 1 through 5. Okay, we're gonna define those in here because they're gonna need to be new weird things. So do that, what message do we get now? Error in X minus Y, non-numeric argument to binary operator. That's of no use. Okay, so how do we fix this? First, we got to write a test that fails. So we are expecting an error, we're getting an error, but we want it to be a better error. So we got expect error in APAT pair X and Y. And we want this error to be X must be a numeric vector, right? So if we run that, test has failed. That is not the message we're getting. Let's make it the message we're getting. So we pop back into APAT pair R. So you have now a bunch of files called APA_T pair R. The test one starts with test, so that makes it a little bit easier. This one's in the R directory. If you get a little bit confused, or like you've got multiple files up here called APA_T_pair.R, close them down, go back into here. We're editing the one in the R directory that defines the function. Okay, so they can't be identical. Now, we also want to check if not is numeric X, then stop. What do we say? X must be a numeric vector. So we're going to do actually like, we're going to check X, and if X is numeric, we're going to check Y, and then give them X must be a numeric vector or Y must be a numeric vector. So let's go back into APAT pair, and let's just swap the order of these, Y and X, and then this will be Y must be a numeric vector. I should have called these A and B because it's confusing when I start swapping the order. But okay, so we've customized it. It'll even tell you which one's not a numeric vector. If they're both not numeric, then you'll, again, it stops after the first error. So if X and Y were identical, it would give you this error. And then if you like make them not identical, they're still both non-numeric, then you get this error and stop. And then if you fix X, but you don't fix Y, then you'll get this error. It won't go through all of the possible errors and then show you that. You could make it happen, but that's a lesson for another day. All right, so save that. Let's run these tests. So it's gonna load the demo package for us. And we've passed everything. So test-driven development, we've added that feature. There are other things that you might want to check. Are they vectors greater than, like, what's the minimum number of things you could possibly do a t-test on? Do you need to warn people about that? Or at some point, do you need to just like trust that when people are getting errors, they're going to go figure out what's going to happen? So you can go overboard with this process, but it's an interesting process to go through, trying to anticipate what errors are people going to make with your functions, and how do you rewrite the the error message to actually be helpful in the context of your function. There's a really outstanding, so in the further resources in the chapter, I linked to testing basics from Wickham's book, and then Jenny Bryan's documentation for the testthat. And they're both fantastic resources for learning a bit more about unit tests. And then there's some practice questions. So set up some tests for the round 0 function. And I've suggested a few things you could do with that. And how to do test-driven development to add a custom error message if the length of your vectors X and Y aren't the same. So they have to be the same for a paired samples t-test. See what kind of error message you get by default out of the t-test when you try that, and then customize it to be a little bit user-friendlier. And then you can add some further sense checks for self-res at or unit tests for any functions you've created. All right, so that's it for us today. Do people have questions? Let me see. No, James has to go. All right. Has anybody got questions? Awesome. And one quick thing, you can use testthat like in a script, so not in an R package, but you can load testthat at the top of a script and use these sort of expect error, expect equal, expect true, to write little tests for, say, data that you've loaded. You've loaded and wrangled some data for a project, and you want to run some tests to make sure that that's all worked right, and that in the future the tricky bits don't break themselves when you've collected more data, etc. You can write tests using this as well, and it will just create an error and stop your script when you get to that point. All right, hopefully see you all next week. I'll stop the recording here.